Students, in this video, we will learn about the Coulomb's law, and we also have to learn why the Coulomb's law is called Coulomb's inverse square law. And firstly, we have to understand what is the concept of Coulomb's law. Okay, to understand this, consider about point charge Q1 at point A. Around this point charge, here area of influence will be there. In the area of influence of this point charge, take another point B. Let at point B, here another point charge is placed, that is Q2, and the distance of this point charge is R. Okay, because this point charge, this electric charge is in the influence of this point charge. That's why this point charge will experience some force. This force is called electrostatic force. Okay, so this force will be force or electrostatic force on second charge due to first charge. And what will be the direction of this electrostatic force? The direction of electrostatic force is always along the direction, along the line joining two point charges. Okay, in the first case, if this is positive charge and this is also positive charge, means like charges, in this case the direction of electrostatic force will be along this direction. Okay, and this force will be F21. If this is negative and this is positive charge, in the case of unlike charge, then the electrostatic force experienced by the second charge, the direction will be along this direction, F21. Okay, but in both cases the direction of electrostatic force will along the line joining two point charges. Okay, in second case, because the first point charge is also in the area of influence of second point charge, that's why this point charge will also experience some electrostatic force. So we can see here, let this is first point charge and this is second point charge, and this is the distance between them. Let this is positive charge and this is also positive charge, means in the case of like charges, force experienced by first point charge, the direction of force will be along this direction. In the case of like charges, this will be force experienced by first due to second. If this is negative and this is positive, then the electrostatic force, direction of electrostatic force will be along this direction. Okay, this will be F12. We can see in both cases that in the case of like charges, the force, electrostatic force, is repulsive force. Repulsive force means the direction of this force is along this direction. In the case, in this case, the direction of force is along this direction, away from this point charge. And in the case of unlike charges, the force, electrostatic force, is attractive in nature. In the second case, for unlike charges, this force, electrostatic force, the direction towards the point charge. Here, towards the point charge for unlike charges. Okay, now here we don't want to here discuss about the direction of when the electrostatic force. We have to only consider about the magnitude of the force between two point charges. Okay, in both cases, the force exerted by first charge on second charge will be equal to the force exerted by second charge on first charge will be equal, means F21 will be equal 1 2 1, 2. Okay, force exerted on second charge due to first charge. This is force exerted on first charge due to second charge. These are equal, and these can be written as F. This is the electrostatic force between 2-point charges. Okay, we have to calculate the magnitude of this force. Okay, now firstly, Charles Coulomb investigated that the force between 2-point charges, or the magnitude of the force between 2-point charges, is directly proportional to the product of the magnitudes of 2-point charges. And he again investigated that force between 2-point charges, or the electrostatic force between 2-point charges, is inversely proportional to the square of the distance between them. Okay, this is first, and this is second equation. On combining both equations, F is directly proportional Q1 Q2 upon R square. Okay, now why this law is called inverse square law? Because this is the force, the magnitude of force, and the in this formula here the square of distance is taken here. That's why this law is called Coulomb's inverse square law. Okay, now this is third equation. Now F equal K Q1 Q2 upon R. This equation can be written as F equal K Q1 Q2 upon R square, where K is the proportionality constant, and here this proportionality constant is called the Coulomb's constant. And in SI system, the value of K is 1 upon 4 pi epsilon naught. 4 pi epsilon. Here epsilon is the permittivity of medium. Okay, this is the permittivity of medium. What is the value of permittivity of the medium? So here, of which medium? Where 2-point charges are placed. So the value of epsilon, you know that the epsilon R is the relative permittivity of the medium, is equal to the permittivity of that medium where 2-point charges are placed to the absolute permittivity. So epsilon will be epsilon naught into epsilon R. Then the value of K will be 1 upon 4 pi epsilon naught into epsilon R. If here in this medium, here free space is there. Free space means in the vacuum or in the air, relative permittivity epsilon R is equal 1. In this case, K is equal 1 upon 4 pi epsilon naught. Then the value of force or electrostatic force acting between 2-point charges in any medium, not in any medium, in vacuum or in air, will be F equal, from this equation, fourth equation, F equal 1 upon 4 pi epsilon naught, and Q1 Q2 upon R square. Okay, this is another formula of the electrostatic force. Okay, here epsilon naught is the permittivity or absolute permittivity or the permittivity of vacuum or of air, and the value of this absolute permittivity is equal 8.854 into 10 to the power minus 12. This is the value. Okay. This value is Newton meter square per Coulomb square. Now, the value of 4 pi epsilon naught, on putting the value of 4 pi and epsilon naught, 1 upon 4 into 3.14 into 8.854 into 10 to the minus power 12 Newton meter square per Coulomb square. Why this unit is there? From this equation, the SI unit of 1 upon 4 pi epsilon on transferring the value of r square, transferring the r square, f into r square upon q1 q2 equal 1 upon 4 pi epsilon. So the SI unit will be Newton meter square upon Coulomb square. So the SI unit of 1 upon 4 pi epsilon naught will be Newton meter square per Coulomb square. Now, on putting the value of 1 upon 4 pi epsilon naught in this equation, fifth equation, so F will be 1 upon 4 pi, this value is 9 into 10 to the power 9. Then F will be 9 into 10 to the power 9 into Q1 Q2 upon R square. On putting the value of 1 upon 4 pi epsilon naught in this equation, this is the final equation of electrostatic force between two point charges placed in any medium or in vacuum or air. So this value is the electrostatic force in vacuum or in air. Okay, thanks.